Good morning. In this video, we will be discussing some problems related to performance of the computer. So let's start with the first question. Assume that there are two machines as given below, which is machine A and B, and the frequency clock rate for machine A and B is given in megahertz, MIPS rate is given, and CPU time in seconds is given. When you look into the CPU time, it's written 12x and x. What does it mean? The CPU time for machine B is x. The CPU time for machine A is 12x. That means 12 times longer than the time of machine B. That is the meaning. Okay. Now the first question, what is the relative size of the instruction count? That is IC. They are asking the IC, relative size of the instruction count for the program running on the two machines. So for that, let's consider the MIPS rate. Okay, so you can express MIPS rate like this. MIPS rate divided by 10 power 6, that is equivalent to IC divided by the execution time. Okay, so let's have this formula so that we can able to find out what is the relative size of instruction count. So I want the IC. So the IC is equal to, so when you cross multiply, you will have T multiplication. Can you get the idea? MIPS rate divided by 10 over 6, 10 power 6. It's not 10 over 10 power 6. Okay then. So we are going to use this formula to calculate the relative size of the instruction count. Okay then. So let's see for, okay, let me do it here. So let's do for machine A. Okay, IC for machine A. So let me write A. Instead of writing machine A, let me write it A. So the time is T means CPU time, the execution time, whereas 12x. MIPS rate for the machine A is 2 and divided by 10 power 6. Fine. So this is for the machine A. Let's do for the machine B, instruction count for machine B. So the formula here is T, which is CPU time, which is equivalent to X, multiplication. MIPS rate is 40 divided by, as per the formula, 10 power 6. Okay then. So here from the question, you can say that machine B is having less time than machine A. See, machine A takes 12 times the time of machine B. So this is the slower one. This is the faster one. So I'm going to calculate the ratio. So the ratio of the instruction count, okay, the ratio of the instruction count of machine B to A. Okay then. So what I am going to do, so as per the question, you can say that machine A is little slower than the machine B. Okay then. So the ratio of the instruction count of machine A to B, okay, A to B is equivalent to, so let me write it. So the ratio of instruction count of the machine B to A, because B is having the less time and A is having the bigger time. So it's B to A. Okay. It's equal. I'm going to calculate the ratio. So what is for B divided by what is for A? So what is the instruction count for B? Okay, you may have some instruction count for B divided by instruction count for A. You just calculated it. So let's write it. X multiplication 40 10 power 6, here 12x multiplication 2 divided by 10 power 6. So when you cross multiply, so this and this will be gone, and here x and x will be gone, and when you divide this, you will have 20 over 12, which is equivalent to, you can use calculator. 1.67. So this is the ratio of instruction count of machine B to A. So why I say B to A? B is having the less time than A. So you need to go with this sequence, okay, which have the less time to A. So how do you calculate the ratio? Ratio goes in the form of something divided by something, okay. So I say ratio of IC to B to A. So what is the instruction count for B divided by for the machine A? So you just have for B divided by A. So when you cross multiply everything, you will get 20 divided by 12. So here it's 40, here it is 12 and 2. So when you reduce, you will get 20 divided by 12, which is 1.67. So this is the relative size for the question, relative size of the instruction count. Okay, so this is the idea. Now let's move on to the, what is the effective CPI of two machines? Effective CPI. So let's calculate the CPI. So let me write CPI for machine A, which is equivalent to, how do you calculate? Very simple. You have the clock rate divided by the MIPS rate. Okay. So what is your MIPS rate? Clock rate divided by the MIPS rate. So here you have the clock rate for the machine A, which is 50 divided by MIPS rate is 2, which is equivalent to 25. So this is the CPI for machine A. So let's do the CPI for machine B, which is equivalent to, clock rate is 400, so you can take it from the question. And the MIPS rate is 40, which is equivalent to 10. Okay. So in this way, you can calculate the effective CPI for the two machines. Okay, so before going to the next exercise, let's come to the CPI, the formula that we are using to calculate the CPI. Actually, the formula for MIPS rate is equivalent to frequency divided by CPI times 10 power 6. So this is the formula we normally use for the MIPS rate, to calculate the MIPS rate. Now we have the MIPS rate in the question, we have the frequency in the question, and now we want the CPI for this question, is it? So I'm going to tell you how do I get this formula. That's the thing. Okay. So let's see. So CPI is equivalent to, when you cross multiply, you have the frequency divided by MIPS rate and this 10 power 6, it comes here, is it? This 10 power 6. But when you see, when you are calculating the MIPS, the CPI, I use the frequency divided by MIPS rate. Okay, so where comes the 10 power 6? Just go and check the question. When you are having the frequency, which is clock rate, F is the clock rate, it is in megahertz. When you say megahertz, it is 10 power 6, 50 and 10 power 6. And as per the formula, there is a 10 power 6. Here it is. Do you see that? Here it is 10 power 6. So below also you have 10 power 6. So both will be cancelled. So that's what I did not write here, the 10 power 6. If you don't write, because the clock rate is given in megahertz. Megahertz means 10 power 6, remember. And the formula also has 10 power 6. On the top 10 power 6 and the numerator and denominator has 10 power 6. So it will be cross out. So that's the thing, I did not mention it here. But if you want to write and you use cross out, it's fine. Okay, another exercise related to the performance of a computer system. Early examples of CISC and RISC design are VAX 11, 780, IBM RS 6000 respectively. Using a typical benchmark program, following machine characteristics results. Like you have two processor, VAX 11 780, IBM RS 6000. Clock frequency is given here, that is the clock rate in megahertz. See, it's megahertz. And the MIPS rate is given for the two machines, and the CPU time in seconds is given. Again, you see here, CPU time of IBM RS is given in X second, and for VAX 11 machine, it is 12 times longer than that of IBM machine. Can you see that? See, the final column shows that the VAX required 12 times longer than the IBM measured in the CPU time. So this was the one I mentioned. Now again the question is, what is the relative size of the instruction count of the machine code for this benchmark program running on the two machines, and the CPI value for the two machines? So the same question, relative size of the instruction count. So when you are calculating the relative size, as I mentioned before, you are going to calculate the relative size, you are going to calculate the ratio of the instruction count of RS to VAX machine, IBM RS to the VAX machine, because IBM RS is having the short time. So remember that point, okay? So ratio of instruction count of, remember, IBM RS to the VAX machine. Okay, why IBM RS to the VAX? IBM RS takes less time than the VAX. So IBM RS divided by the VAX 1. Okay, so remember that point. Again, we are going to use the same formula. So you know the formula, in the previous exercise I mentioned it. So we are going to use the same formula. So let me calculate. First I am going to do for the IBM, instruction count for the IBM divided by the instruction count of the VAX machine. So this is what I am going to do. So let's say for the IBM RS 6000, so it is X into 18. Divided by, for the VAX machine, it is 12x into 1. Okay, MIPS rate, it's 1 and 18. Can you get the idea? So when you cross, my x and x will be cross out, and you have on the top 18. Numerator is denominator is 12. Okay, so let's calculate 18 divided by 12. You get 1.5. Okay then. So the formula, it's given in the previous exercise. Please note down the formula. So this is the ratio of the instruction count of IBM RS 6000 to VAX 11 780 machine. Okay. And question B is about CPI. I told you already, for the CPI, you are going to divide, because the frequency is given in megahertz. So very simple. So you just say frequency divided by the MIPS rate. If you want, you can write the 10 power 6. It's fine. No problem. It's not a harm. Okay, let's do for machine VAX. So I'm writing short VAX because it's long processor name. VAX 11 780. So I just write VAX. Frequency is 5. It is given in megahertz. And the MIPS rate is 1 and 10 power 6. This is what I told you. In the numerator and denominator, you have 10 power 6. If you don't write also, it's fine. But if you write also, it's not a problem. Because this one will cross out and you will get 5 only. Let's do the CPI for the IBM. So let me write only IBM. Frequency is 25. So let me write the megahertz. So it's 10 power 6. And then 18 is the MIPS rate. And you have the 10 power 6 as per the formula. So they all will cancel. and when you divide the 25 by 18, you will get 1.388. So let me write 1.39. Okay, so in this way we can calculate the relative size of the instruction count and CPI values. Thank you.